A very good morning to Dr. Nazrul. So today our group number 5 is going to present our data communication and network project. Our group consists of 6 people: Tan Lee Jiang, Wong Chun Kiat, myself Kessigan, Rohaizad bin Rosli, Amirul Hafiz bin Anuar, and Isaac Ryan Koirin. So let's get into the introduction. So we have designed a secure and a scalable network for BITS 05 Sendrian Berhad covering one headquarters and two branches via both wired and wireless connections. Variable like subnet masking, or known as VLSM, was used for efficient IP allocations. The project includes network topology, device configuration, and connectivity testing to ensure full functionality and full scalability. We got 5 objectives that we need to fulfill via this project. The first one is to design and implement a complete network connecting the headquarters and branches via wide area network, using VLSM for efficient IP addressing and future scalability, configure routers, switches, and end devices across Shah Alam, Kulit, and Skudai, deploy reliable wireless solutions for mobile users, and finally, to apply network segmentation to enhance security and performance. So let's continue with the presentation.
We're going off the logistic details, which is HQ Shah Alam, or he call it as headquarters. Let's break down infrastructure at HQ Shah Alam. We use Cisco Packet to simulate. The first floor, which is the technical department, has 4 wires connected via central switch. The second floor, management, has 6 wire PCs, 4 wireless PCs, and 2 notebooks supported by wireless routers. The third floor, which is the server farm, has 4 critical servers for the centralized resources. And the fourth floor, which is the sales and marketing, has 5 wireless PC and 5 notebooks for its flexibilities. So this design ensures dedicated resource for each department while maintaining capabilities. Next, we go into the logistic details, which is the branches. So the branches Kulit features has a service department with a 4 wire PCs and staff hostel with 5 wireless notebooks. And Skudai includes with a service department with 5 wire PC and a staff hostel with 10 wireless notebooks. And the fun fact is the number of devices in this Skudai service department was adjusted to 5 as a node to our group 05. These branches are interconnected with HQ via optimized WAN link.
Move to network topology. This is overall network topology for our project, like green square for the HQ Shah Alam, cyan square for the Kulim branch, pink square for the Skudai branch. All networks are connected using router and switches. IP address was done using VLSM to ensure efficiency address allocation. The topology ensures stability, connectivity, security, and scalability across all department and location.
So I will present the IP address part. So for our project, we are using VLSM. It's a technique used in IP networking to divide a IP address block into subnet of different size, rather than being forced to use the same subnet size every day. So it's helped to minimize the IP wastage and makes the network more efficient and scalable. So for our HQ Shah Alam, we are not applying the VLSM because it's used a fixed 26 blocks. So for company network, we are divided to 3 main locations, which is headquarters, Shah Alam, Kulim branch, and Skudai branch. So since we are our group number is 05, we are using 0 plus 5 equal to 5. The headquarters Shah Alam IP address will be 192.168.5.64. So for the branch, we are using 10.0.0.0. The total IP address will be 512. So since we have 2 branches of it, so we have to divide it to 2. Then we will get 256 of it. Then so 256 equal to 2 power of 8. So the new prefix will be 24, and the subnet mask will be 255.255.255.0. So this is the IP address allocate table. So for HQ Shah Alam, the table will show the department and flow, the device name, the IP address, the subnet mask, and default gateway, and their interface. Also the table for branch 1 and branch 2, the same things, and we are using this 2 of these table to do our project. Then I will pass to Lee Xiong for the project demonstration.
Now I will present the demonstration using the Cisco package, and how we try to ping the HQ host and branch 1 and branch 2. And I'm using one of the hosts in HQ to ping any one of the hosts in HQ also. This is the IP address for the one of the hosts in HQ, and this show the status is successful. And for next one, we try to ping the house house one, house A for the branch one, and this is the IP address, and yes, it also can access it in successful. And next, we try to ping the branch one and house B, and the IP address is 10.0.1.9. It also can successful. And next, we try to ping the branch 2 is Gudai, and the IP address is 10.0.2, and it also can ping it. And next, we try to ping the uh, branch 2 for Skudai, and for the staff hostel, where is the IP address is 10.0.0.21, and that also can successfully ping it. And next, we try to use this PC host access the web server using the web browser in place. And this also can ping the web server. And now we try to use the branch one host to ping one of the HQ PC hosts, and also the branch one house B, and also the branch two one of the PC hosts. And now this is the house B for the branch one, and the IP address is 10.0.1.9, and this also can ping it in successful. And next is we try to ping the HQ department PC host, where the IP address is 192.168.5.66, and this also can ping it. Next, we try to ping the branch 2 with the IP address is 10.0.0.2, and this also can ping it. And now we use this branch 1 PC host to access the web server also using the web browser. This also can access it. And then last, we use the branch 2 PC host to ping the branch 1 and also the HQ. And for first one, we try to ping the branch 1 PC host where the IP address is 10.0.0.21, and it's also successful to ping it. And next, we try to ping the ground floor for service department based in the branch 2. And the IP address is 10.0.1.5, and it also can ping it. Last, we use the HQ host IP address, where is 192.168.5.77, and it also can ping it with the HQ host. And last, we also show the web server using web browser in this. And also this one can also successfully access the web server. So that's all for our demonstration.
Okay, so I will be presenting the conclusion part. So we began the process by analyzing the network requirement for each of the site. Based on this, we use the VLSM, which is variable length subnet masking, to efficiently allocate the IP addresses. This allowed us to minimize IP wastage and ensure each subnet had just the right number of addresses for its current and future needs. Once the IP plan was finalized, we moved on to the device configurations. We set up the necessary routes, routers, switches, PCs, and other network devices on the Cisco packet tracer. All routing configurations were implemented correctly during the project, including the static routing and the dynamic routing. After configuration, we conducted a comprehensive connectivity test. This included a ping test, trace routes, and end-to-end communications between the HQ and branches. We also tested for redundancy and failover scenarios where applicable to make sure the network remains operational under various conditions. I'm happy to report that our network is fully operational and meets all of the BITS 05 ICT requirements. It is designed to support not only the current operations but also to scale efficiently with future growth. In conclusion, this project has been a success from planning to execution. The network is stable and secure and scalable, ready for development. Thank you.